Bismillahirrahmanirrahim. Welcome to the channel. My name is Asim Amjad. In this video lecture, we solve a problem related to shear stress in a beam subjected to non-uniform bending. So the problem is a steel beam is subjected to a loading and it has a cross section as shown above at the location on the beam where the maximum shear force is located, and solve for the transfer shear stress at the neutral axis and at point C on the cross section as shown here. At point C, that is the distance at this point is 6 inches. The width of the rectangular cross section is 10 inches and the height of rectangular cross section is 25 inches. So first we have to solve this problem for finding the maximum shear stress. As you know, we already covered this problem in our previous video lecture. So here is the maximum shear force that is located here, that is 23,750 pounds, and here you see the negative shear force, that is 23,750 pounds. We already solved this shear force and bending moment diagram in our previous video lecture. So if you didn't see that video, so first have a look. Okay, now let's come to the problem. In part A, we have to find the shear stress at neutral axis. So this one is the expression related to the shear stress, that is tau is equal to V times Q over I times B. So we derived this expression in previous video. So substitute all the terms one by one. For V, the shear stress is 23,750 pound. B is the width that is given, that is shown here, that is 10 inches. So B is 10 inches. And for finding the area moment of inertia, we know that it's equal to 1 over 12 time base time height cube. So substitute the base and height value in this term and the area moment of inertia would be 13,020 inch per 4. And for finding the Q neutral axis distance equal to y bar times A, and y bar is located at this point, or we consider the lower part of the neutral axis. So y bar is the neutral axis of this lower cross section. So we can calculate this neutral axis by simply dividing the 12.5 divided by 2. So we know that the total height of this rectangular cross section is 25 inches, and this is the neutral axis of the rectangular cross section. So above at this point to at this point the height is 12.5, and similarly at this point to at this point this height is 12.5. So we want to find the central axis of this lower part of the cross section. So the value would be 12.5 divided by 2 times its area, that is 12.5 times 10, and the answer would be 781 inch per cube. So substitute all these terms into this equation, then the shear stress at neutral axis would be 142.5 psi. That's the answer. Okay, in part B, we have to find the shear stress at point C, which is 60 inches above the neutral axis. So we know that what the shear stress is, what the B, and what the area moment of inertia. So for finding the Q at point C, we have to apply a cut here, and this one is our required rectangular cross section that we are interested for, and y dash is the distance at this point to at this central axis of this rectangular cross section. So we can find this central axis by simply calculating 12.5 minus 6 divided by 2. So we know that the distance at this point to at this point is 6 inches, and the center of this point would be its half, so it's 6 divided by 2, and the distance from this point to this point is 12.5 as already told. So after solving this term we get the y bar value, and the area of this rectangular cross section is 6 times 10, and the answer would be 570 inch per cube. After that, substitute all these terms into this equation, then shear stress at C point would be 104 psi square, and that's the answer. Just to cross check, we can find the QC at the bottom of the cut, as we cover this concept in our theory lecture. So for finding the QC at bottom of the neutral axis rather than above of the neutral axis, so we know that the height of this side is 12.5 minus the distance at this point to at this point is 19. How 19 is came from? We know that the total height of this rectangular cross section is 25. 25 minus 6 would become 19, and y bar is the center of this rectangular cross section, so 19 divided by 2 would give this value, and then simply minus this term into 12.5, and the answer would be the y bar that is located here, times the area of this rectangular cross section, that is 10 times 19. Now substitute all these terms again into this equation, and the shear stress at point C would be 104 psi, that's same as we calculated in above. So it's all about today. Next time we will solve a problem related to non-uniform bending but other than rectangular type of cross section.